Okay, so there we go. People should be able to hear me. Can people hear me? Okay, cool. So I've started just with the telescope pointing at the moon. This is just a little piece of the moon. I can zoom out to, I'll actually start by zooming out. So the way I've zoomed out is added together 2x2 clusters of pixels on the camera, which is why it's much brighter now. So I'll just turn down the exposure to fix that. So there we go. This is the moon. It's flipped sideways and rotated compared to what you'd see in the sky, but you should be able to tell which way it should be if anyone goes outside and takes a look. So if anyone does go take a look at the sky, the moon is pretty much directly in the south and very easy to find. The little dot above it is Saturn, and the bigger dot to the right of that is Jupiter, which we'll be looking at both of later when we're done with the moon. So I think this is in about as good of focus as it'll get, and as good of frame rate. I can turn that up a little, actually. So the main things that you'll see on the moon is that, unlike last time I did this, when the moon was full, we have, instead of the full moon, the moon ends at the top of the image with this section where it goes from daytime to nighttime up there. And that's where all the interesting stuff is, because all of the details that you can see in there, you can only see because of the shadows. There are craters at the bottom of it in the picture too, but you just can't see the shape of them because we can't see any shadows on them because they're lit from directly above. Whereas at the top end, you can see mountains, you can see craters, and so on. So I guess now I'll zoom in. I'll see if I can flip the image so that it's the same as it would be in the sky. But I'm not sure if that's easy to do here. Okay, so I don't think I can do that easily here, but I can rotate the camera just as it's placed into the telescope. The moon will remain not exactly as it is in the sky, but I'll rotate it so that instead of being rotated, it's just flipped left to right. If you were to go outside and look at the moon, you'd see that it is the same about the same angle as that, except flip left to right. I'll look for next time if I can flip it left to right in software, but I think that might be different software that I'm mixing this up with. Anyway, I'll now zoom back in so we can take a closer look. Oh, I was just, I was looking at my capture software, so I missed the chat. I don't see any stars to the left of the moon, but that's probably just because it's a little hazy where I am. But if anything in that direction would just be a star, and no, the Earth is not flat. I hope that's a joke. So, I'm going to need to switch back to my other window because there is a few second delay on the stream, so I don't want to control my telescope by looking at the stream view. So, I guess I'll just start at the north because there's no particular reason to start anywhere. So up here you can really see, like on the left side where the sun's coming straight down to the surface of the moon, you really can't see any details. You can see a few brighter spots where recent craters have kicked out brighter, like more jagged bits of rock. But for the most part, you can't see that much. Whereas on the right side, you can see plenty of detail. You can see lots of details in the craters, and particularly these Apennine Mountains right here. They're named after the ones in Europe, which are in fact part of a big crater. You can only see half of it tonight, but this circle right here is an enormous crater. Right at the beginning of the solar system's history, there was a huge number of comets and asteroids and other large bodies. So the moon has these big dark areas, which are usually referred to as seas. Here's a smaller one, a couple smaller ones. You can see that they mostly have the pattern of dark circles in lighter material. And what that is areas where very large impactors produced large craters about 4 billion years ago. And those later filled with lava because the moon used to have some geological activity, though it is cool now. Those mountains are formed of the rim of a crater like that. And if you look, one thing that you can notice is that those were towards the end of most of the craters on the moon. So if you look, or I guess here's a good example. You can see lots of craters in the lighter area, but in the darker area there's very few. And what that means is that almost all the ones in the lighter area predate the darker area filling with lava, because most of those large craters were from very early on. Once the planets formed, their large gravity wells kind of cleared most of the impactors out of the solar system, especially Jupiter's. So the dot above the moon in the sky is Saturn, and the bright one to its right is Jupiter. Just looking back at the chat. The bright spot a bit southwest. Which direction is southwest? The moon is flipped, so it's hard to... do you mean this bright spot that I've centered here, Vedant? So that spot, I can turn down the brightness a little, so we get a better view of that. But so that's just two craters that happen to be fairly recent, so fairly bright, and also close by. They just appear bright because the camera natively does not have great dynamic range, so things saturate and look bright, especially if they do have direct sunlight from the top. Also, I'm kind of stumbling around in my pointing on the moon because the arrows on my telescope control don't match up to the directions in the camera unless I specifically set them to, which I haven't because it changes every time. So there's another question that I'll answer the serious half of. There is no dark side of the moon. There's a far side of the moon because the moon spins at the same speed that it orbits around the Earth. But as you can see here, sorry, I'm just trying to sync I'm mixed up because my video isn't synchronized with the actual video that my hand control is controlling. So here, the left side of the screen is bright, and the dark side of the screen is, or the right side of the screen is dark, and the reason for that is just that the sun is to the left at the moment in the screen's reference frame. But 2 weeks ago, it was the opposite. The moon was on the other side of the Earth. And if I had pointed at exactly this part of the moon, the dark and light sides would be flipped. So yeah, there is no real dark side or light side. There's a near side and a far side, and the sun just appears from our point of view to travel in a circle around it over the course of a month. So I'll find a couple particular spots of interest. Right about here, if you can see my cursor, I think you can see my mouse cursor. Yeah. So right about here is where the Apollo 11 mission landed. First people on the moon in 1969. Some of these features are visible in onboard videos that they took back then. Oh, whoops, I didn't mean to do that. But we don't have nearly enough magnification here to see anything they left behind. For reference, the bigger craters that you can see here, like this one, are tens to 100 kilometers across, whereas the things that we left behind on the moon are a few meters across at most. There's a few other sites of landings that we can probably take a look at. I have a map opened. Oh, so many of them are actually in the currently dark areas of the moon, but a few should be visible. Apollo 16 landed somewhere here. I'll check the map again. I'll make sure that that is precise. Okay, so somewhere in this area. Apollo 18 landed right beside these mountains here. So I'll turn up the exposure a little to get that shot brighter. Or no, 15, not 18. Apollo 15 landed right about here. And Apollo 17 I believe 17 was right around my cursor somewhere here. So one cool thing particularly with Apollo 15 is if you look up pictures from that mission, and like if you take a screenshot of this view right here, you might be able to match up some of the mountains and other surface features with things that they saw on the ground there, because they did have the most interesting, like, large-scale geology, I think, of the Apollo missions because of all those mountains there, and there's other stuff like craters and lava tubes that they saw that were fairly large. So all the Apollo missions, they didn't all land very close together. Those are just the ones that are easily seen here. I'll post in the chat the link that I'm using. So that's the map of the One's on the near side, at least. I think... Um, okay, yeah, so they all landed around the borders, I guess, between newer and older rock. If you want more detail on it, you can Google, or like the Wikipedia articles on each Apollo mission will give a fairly good rundown of why each one landed where it did, like what the science objectives were at each particular spot. Also, one important reason is they landed on the darker areas, the seas for the most part, because those areas are flatter and easier to land on. Just refocusing this because I think it might have drifted a little. Oh, I'm trying to focus it with the YouTube video, which has a delay. That's why it's not working. Okay, there we go. That's sharper. So now I'll take a look at one of the other more interesting features on the moon, which is something, one of the smaller things that is actually visible when you look at it. I'll just have to check the map again because I'm not sure exactly which crater it is. Anyway, while I check the map, I'll say if you look at this view of the moon, there are a number of brighter lines that you can see coming out from craters, and the biggest ones are coming out from a crater at the bottom right of the field of view here. I think it's this crater right here. Oh, there's a bird or a plane going across it. Anyway, I think this crater right here, called Tycho, was recent enough and large enough that it produced those lines of debris extending out from it. So now I'm just going to check that that one is indeed Tycho. It's more prominent a bit later in the month. It becomes very bright and obvious, but right now it's not. Okay, I'm not sure exactly which one it is. Maybe. Oh yeah, I think it is that one that I had indicated. I think I was looking at this at a bit the wrong angle. It's easy to get disoriented with the moon, because it's hard to tell exactly which way is up in this view versus any maps. But yeah, so that crater there produced these giant streaks of ejecta, which you can even see. I think this is one all the way up here, and there's more in the area that's currently nighttime. And some of those on a very good night at the right phase of moon, probably when it's full is easiest, are visible to the naked eye. Anyway, so that's the more interesting specific things on the moon. So now I'm just going to pan over the whole thing, and if anyone wants to take a longer look at anything in particular, just remember roughly where it was in up, down, left, and right directions, and I'll try to go back to it and explain it if there's much to explain. So starting at the top, Okay, someone's asking which the Sea of Tranquility is. I think it's the one that's currently at the bottom middle, but I'll just check because I'm not entirely sure. So the Sea of Tranquility is the one that, it's this one. It'll be centered in the stream in a second. It's the one that I had previously pointed to Apollo 11 having landed at the south end of. So these are all called seas. They all have their own name, except for the big one that's at nighttime right now, which is called an ocean. But the Sea of Tranquility is this one here at the center. So, question about why all the large seas are on this side of the moon. They aren't all, but most of them are. And I think that is an area of active research. But yeah, I forget exactly the reason. I can see if there's a quick answer on Wikipedia. Um, okay, so Wikipedia says that the difference is due to the moon's crust being thinner on this side. Um, which would just be due to the influence of Earth's gravity in the moon's early history. Okay, so if everybody's done with the moon, then I'm going to move on to the next thing. So I'll give a few seconds for any further questions, and then I'll move on to Saturn. Okay, so this will just take a minute. I actually forgot to align my finder scope, the small telescope on the side of the main telescope that helps find things, which means I'm going to have to go back to the moon to do that, because the moon's very easy to find with or without. Okay, so I'm just going to center on the Sea of Tranquility and then center my scope to also be there. Oh, we had it. It just wasn't bright enough and I didn't notice it. Saturn, I will turn the exposure up. It's quite a lot further away from the sun than the moon is, so it appears much dimmer. I'm also going to zoom in by adding a lens between the camera and the telescope. For the moon, I didn't do that because it's big enough that the field of view is nice to have with lower magnification, but here Saturn's very small. So, this is pretty dim and noisy, but that's kind of unavoidable with Saturn. It's quite inherently dim. It's harder to take good pictures of than Jupiter is. Want to turn the gain down, but then it'll be... Okay, well, it's going to be noisy. Hard to avoid. If I were to make it less noisy, it would be blurrier because it would be a longer exposure. Okay, so there we go. There's some fairly good detail there. So what you'll be able to see is the main thing, obviously the ring, the gap. Okay, so I just came back to the chat. There's a lot of hot pixels. I think the video is compressed a bit, so you can't see as many as I can, but there's a lot of them there. I've turned the sensitivity and exposure up much higher than usual. Usual meaning what I'd use on the moon. So questions. Venus is only in the sky immediately before and after the sun is. Like Venus is... Oh. Did I lose the stream? Oh, no. Okay, there, it's back. Okay, so... Okay, so Venus isn't in the sky. Venus is always close to the sun in the sky because it's close to the sun in real three-dimensional space. Same is true for Mercury. They're only visible immediately before sunset or after sunrise. The name of the gap between Saturn and its ring, which you can see just a tiny bit here, is the Cassini division. If you want to see it in the stream, Google Cassini division so you know what you're looking for, and you'll be able to see it much better in the stream because it is very faint at the moment. We can see Titan. I will need to turn up the exposure even more for that, but I'm going to do that in a second. And the stars around it aren't actually stars. They are issues with my camera. Also, it's drifting off for... I'm not entirely sure why it's drifting off. But okay, there we go. So the stars around it are issues with my camera. They are different colors because each pixel on a camera is actually 4 pixels. 2 of them are green, 1 of them's blue, and 1's red, and that's how you see color. So the red ones are issues with red pixels, the green ones are issues with green pixels, and the blue ones are with blue pixels. So the 2 main details you can see in this are, because of the angles between Saturn, us, and the Sun, its rings cast a couple of shadows on the rest of it. So you can kind of see at the bottom left, there's like a tiny dark separation between the ring and Saturn. That's the shadow cast between them. You can also see where the ring goes behind Saturn on the right. You can see the shadow that Saturn casts on the ring. So now I'll try to find Titan. I'm just going to quickly look up exactly where it is, or it's probably close enough to find easily. So now things are extremely noisy because this is a much longer exposure than the camera's intended for. Okay, actually I am going to figure out exactly where Titan should be, because that'll make it easier to find. I can just point there and turn the exposure up until I see it. So I'm using the program Stellarium to do this, which is linked to on the observatory website. It's a planetarium software that shows you pretty much what you'll see in the sky with a telescope at any place and time. So Titan should be visible here. Oh yeah, so this is a terrible image, but you can see Titan. It's it's where my mouse is here. You can see it moving. So all the things that are problems with the camera are not moving, but Titan and Saturn are between exposures, and the frame rate's so low because the exposures are 2.5 seconds. And this dot that you can see here is Titan. It would look much better with the actual eye or with a camera that was intended to do this, but my camera that does video through a telescope is not intended to do this. So someone's asking about globular clusters. Unfortunately, we can't look at that kind of thing via streaming, because seeing a globular cluster with a camera and a telescope requires a substantial amount of exposure and isn't really the kind of thing that I can do in a video. I could take a quick picture and show it, but I'd need to get out my other camera and it wouldn't be very good because the skies here are so light polluted. So for these events, we're generally going to be limited to solar system objects. Mars will be up soon. It's probably above the horizon right now, but behind trees and stuff. In a month or so, it'll be better. Otherwise, it's Jupiter, Saturn, and the Moon, and occasionally the Sun, if the Sun does anything interesting, because I have another telescope that is specifically for seeing detail on the Sun. Anyway, I'm going to go back to the view of Saturn, and I'll answer that question about Titan. Titan does not have water, or maybe it does, but it's ice. Titan is very cold because it's all the way out there. It appears to be extremely like Earth in many ways, but that's because it has an entirely different chemistry. So water's frozen there, but natural gas is a liquid. So rather than having like sandy beaches and oceans of water, Titan has icy beaches and oceans of methane. It's still an interesting place to look for life because it is known to have complex chemistry, and while it would not have life familiar to us, it would have potentially the ability to have a kind unfamiliar. But we don't have that much data on what's going on the surface there. There's no light really on the surface because its clouds are so thick. So the one time we've landed there, we're relying on batteries rather than solar panels. So it was a short duration mission. Sorry, I'm trying to center Saturn. It's drifting around. There's a bit of backlash in my telescope's gears. Okay, someone asked who this is. If that's referring to me, I am a PhD student at Carleton in physics. I do a lot of astronomy as a hobby, so I generally get the TA position showing students the observatory. And I do events like this either remotely or in the actual observatory. Okay, so I guess then we're done with Saturn. There isn't too much to see of it. So I will move on to Jupiter. This will just take a second because Jupiter is, I think, far enough to the other side of the sky that my telescope's going to have to spin all the way around. So I'm just going to I'm going to disconnect my camera so the stream will not show anything at all or it'll show a frozen frame of Saturn until I find Jupiter. Okay, it's going around. It'll be moving on its own for a moment, so if anyone has further questions, I'm not doing anything until it finishes turning. So if anybody has looked at the sky, Jupiter and Saturn are quite close together, and the reason that this is taking so long to turn from one to the other is that I'm using a kind of mount called a German equatorial mount that rather than tracking left and right and then up and down, it tracks along the direction of the Earth's axis and then the direction perpendicular to that. So its main axis, instead of pointing up, points at the North Star. And because of that configuration, for the telescope to not run into the tripod, it has to go all the way around if it's going from looking at something a bit to the left of south to something a bit to the right of south. So it's done turning now. I'll find Jupiter and be back in a moment. Okay, I've finished turning around the telescope, so I'm just going to do the in-camera or in-software end of getting Jupiter, and then I will answer the couple questions that have come up since. So this is Jupiter and 3 of its moons you can see right now. I'm just going to change the exposure to make Jupiter first and then the moons later more visible. And I'm going to focus that a little better if possible. Okay, so that's probably about as sharp as it's getting. It is fairly dim for what I'd expect. But anyways, so that's Jupiter. You can see, okay, the video quality is a bit spotty. But you can, I guess, see most of the details. You just see less noise. So yeah, you can see the cloud belts going across it. If you look up better pictures of Jupiter, you'll see that at different latitudes it has a variety of different colors. And you can see the most prominent instances of that here. You can also see, if you look, I'll switch window to point it out with the mouse. But if you look a little bit left and down from center, right here where the mouse is, there's a darker spot. And that is a localized, just darker area of clouds, different chemicals, that is there for complicated reasons. Those are usually more transient, so that'll be something that has come up in the last few years, I expect, whereas the cloud belts and the Great Red Spot, which is not visible tonight, those have been there for hundreds of years to billions of years in the case of the bands, probably. So now I'll turn up the exposure so we can see the moons better. So there, again, there's a bunch of noise visible, but the spots that are wobbling around a little bit are 3 of Jupiter's moons. Just trying to center this a little. There we go. Okay, so just before I explain those, there's a couple more questions. I'm not studying astronomy. I do this mostly as a hobby. I study particle physics, so my PhD involves the development and analysis of data from one of the detectors on the Large Hadron Collider, the ATLAS detector. There isn't very much astrophysics at Carleton. We do have an astrophysics stream, which is mostly there because we have a couple particle physics experiments that border on astronomy. Mainly SNOLAB, which looks at neutrinos, which are extremely rarely interacting particles that come from the nuclear reactions in the sun. But it's not astronomy, like you're not taking pictures of space, you are investigating a process that has to do with astrophysics, like how exactly the sun burns, but we don't use telescopes for any research at Carleton. Yeah, so someone in the chat mentioned Art McDonald. He was one of the leaders on the Snow Lab experiment, and he won the Nobel Prize for their measurements of neutrinos a few years ago. It's complicated. If anyone wants to hear more about it, you can Google, or Wikipedia is probably the best way to go for an easy explanation. If you search Wikipedia for the solar neutrino paradox, it is a imbalance between what we expected from the theory of the sun and what we saw in the neutrinos coming from the sun that was extremely problematic until it was figured out by Snow Lab. And what they figured out is that an entirely new mechanism was responsible for the mismatch. Someone's asking about the telescope. It is a 4-inch refractor. It's designed for use as a quintuplet with a field flattener, but that is more for photography of very dim objects far out into space. So right now I'm just using it with 3 lenses. But yeah, it's... sorry, car coming past, probably loud. Motorcycle, actually. But the telescope itself is about 5 inches across and 1.5 feet long. It's generally much easier to make high-quality small telescopes than high-quality big telescopes. Like, you can get a high-quality small telescope for a reasonable price, and you can get a decent quality big telescope for a reasonable price, but if you combine those two, it quickly becomes, like, no longer an amateur instrument. So anyway, you can see the 3 moons of Jupiter here in this view, and I'm just going to look up exactly what they are. Because Jupiter has 4 moons that are bright enough to be easily visible, you can see them even with pretty much any pair of binoculars. You'd be able to see them with the naked eye, except they're too close to Jupiter for you to resolve them as separate. So I'm going back to this Stellarium software. Oh, we can actually see all 4 if I zoom out a little. So I'll go back down to grouping the pixels in clusters of 4. And then I will pan over a little bit and we should be able to see. I'll turn up the exposure too. Yeah, so there we go. You can see all 4. They're approximately in a line because Jupiter's equatorial plane is approximately pointing at us. So the closest one in currently is not actually the closest one in. It just appears to be because it's right in front of Jupiter right now. It's Europa. It's probably the most interesting because it has similar chemistry going on to what is expected to have been responsible for the origin of life on Earth. 3 of these moons are known to have very large oceans, around 100 kilometers deep, covering their entire surface, with layers of ice on top. 2 of them are thought to be less interesting because the ice, or the water, may be slushy or covered with ice at the bottom too. But on Europa, it's expected that the water is in contact with the rocks. And that sort of thing, having water in contact with the chemistry of a planet's interior, is thought to be where life came from in the first place here. So Europa, along with one of Saturn's moons that is too dim for us to have seen, are thought to be the most interesting places to look for alien life, essentially. So yeah, that's Europa. The next one out is Io. Io is actually the closest to Jupiter. Because it's so close, it has an effect of gravitational friction as it orbits around Jupiter that heats it up an enormous amount, and Io has the most active volcanoes in the solar system. Mars used to have active volcanoes because it used to be hot from having formed out of a contracting and very hot solar system, but right now it's cooled off, whereas Io's friction with Jupiter keeps it constantly hot and gives it many enormous volcanoes. The next one's Ganymede. Ganymede's the biggest of Jupiter's moons, and I think it's the biggest moon in the solar system, if not Titan. But it's similar to Europa, except that it's expected to have potentially more ice than water and less astrobiological interest. And Callisto's the one way out to the end. It's also pretty big, but Callisto is the blackest object in the solar system, or at least the blackest large one, just because of the way the ice on it is with any dirt that may be in the surface ice. Makes it much darker than the ice at the surface of Europa or Ganymede. And it is further out than the other ones in the actual orbits. And an interesting thing about these moons is, so the reason that Io is so hot and the reason that our moon always faces Earth with the same side is because of this gravitational friction between it and the planet. There's a similar effect where resonances build up between the orbits of these moons because they're so big and close together. And because of those resonances, the moons orbit in integer multiples of each other's orbital periods. So I'm just going to look up the numbers exactly because I never remember what they are. Okay, so it's simple. Europa orbits once for every 2 orbits of Io, and Ganymede orbits once for every 2 orbits of Europa. And then Callisto is not quite locked with the other ones. So it's... it will eventually be, but I don't know the timescale of that. But currently, only the inner 3 are exact multiples of each other. Anyway, I'll turn the exposure down again if anyone wants to get another look at the surface of Jupiter. And I'll zoom in again. So yeah, there's Jupiter with its cloud belts. So someone's asking, closest moon is Io. Yes, it's in the actual orbits and real distances. It's Io, Europa, Ganymede, Callisto. But just because of the direction that we're looking at it from right now, the first 2 appear switched. So Europa was the one that looked closest in the picture, and then Io, and then Ganymede and Callisto. And there's like 80 more, but they're too dim to be seen with this camera, at least. I've never tried to take a deeper picture of Jupiter with a different camera. That would be interesting to see how many I can catch, but with this it's only 4. Anyway, in case anyone came in a bit later, I'm going to head back to the moon, and then that's all there really is to see this session. So after that, we'll be done. I'll just need to find the moon, which will take a second. Yeah, so Mars is currently too low to see. I took pictures of it the other night, but that was because I was up until midnight doing that. It'll be more visible. It'll be at its best in about a month. It'll be at its closest to Earth for these 2 years. And it'll probably be visible at this time of night then as well. But it'll be up earlier and a bit smaller after that. So we'll see it eventually, just not tonight. So I'll go around the moon again. If anybody's leaving and thanking me in the chat, you're welcome. Otherwise, thanks for coming. And I hope to have another one of these relatively soon. For now, I'm just going to pan around the moon a little. I will also take pictures of the things we've been looking at and post them on the observatory website. They'll look better than what you can see in the stream because they won't be compressed, and also because I'll have analyzed the data. What you're seeing here is the raw data, and I can do a lot to bring out more detail. As you can see here, the moon looks like it's wobbling, and the reason for that is that the air different temperatures of air are mixing in the way of my telescope. I'll post a link to the observatory website. I should put that in the about part of the YouTube channel, but I have not yet. So there isn't much on the observatory website. I've posted the link there, but I'll try to add a few things to it in the near future. So anyway, different temperatures of air are mixing, so you get the same effect as above a highway on a hot day, and the air becomes blurry. And what you can do to combat that is take a very large number of pictures and use software to interpolate the real picture. Cold nights are actually the worst in the city because it's still relatively warm down here because of all the heating in the houses, and it's colder up there. So you get a much stronger gradient. But one of the things about small telescopes is they're relatively unaffected by that issue. And also you can get around it by taking thousands of pictures and using software to interpolate the real image, which will give you a much sharper view than what you can see in the video. Anyway, I'll zoom back out with the moon. So yeah, this will be about it. I'm just going to pan around the moon in case anyone hasn't seen it yet or wants to see it again. I think this is upside down. Oh yeah, because the telescope flipped around 180 degrees to look at Jupiter, and now everything's at that side of the sky, so the view is upside down relative to what it was with the moon before, and also upside down relative to the moon in the sky. But so yeah, here's the moon. Here's some mountains produced by the big crater that's half visible on the left side of the screen. I can make this a bit bigger. Oh, I can't make it all the way bigger because it's digitally binned. So if anyone missed it earlier, the Apollo 11 astronauts landed right about here, where my mouse will be circling in a second when the video catches up to me. If you want to screenshot this and compare to an actual map this is upside down relative to, you can definitely see some features between the closer in map of all the activities they did and this much wider view. Here's the very cratered south pole of the moon. Oh, it turns out, looking at this, I was wrong before. The shadows have advanced a little and I can see some details I couldn't see earlier. So I had talked about the crater Tycho, which is responsible for all of these lines that you can see radiating out from the impact site, which are just debris thrown by the energy of the impact. And Tycho is this very deep-looking crater that you can see right here. I didn't notice it before just because I think the sun was at a little bit of a different angle relative to the moon, so the shadows weren't there to make it really stand out. But it does really stand out when it is visible. So unless anyone wants me to point at a different part of the moon, I think that's about it. I'm going to shut off the stream and take videos of, I guess, Tycho, the mountains on the moon, the Apollo 11 landing site, Jupiter and Saturn, and I will post those videos to the observatory website in the coming days. Thanks for coming, everyone. I'm glad we can keep these events going during the pandemic, not have the observatory completely empty, in spirit at least. So yeah, thanks everyone. Have a good night.